Hi everyone, my name is Italo Gervasio. I will talk about my article. The title is A Hybrid Automatic Elasticity Solution for the IaaS layer based on dynamic thresholds and time series. The outline, we talk about cloud computing, provisioning of resource in cloud computing, what is upscaling, why set up an auto-scaling is hard, motivation and objectives, performance evaluation, and conclusions in future directions. So, cloud, cloud computing is a pool of computers that people can use them and get charged based on the usage. The on-demand feature of the cloud can be very attractive for small and medium companies, which might not have enough money to pay up front for buying servers. Also, cloud resource can provide an illusion of infinite computational resource, since its size is relatively larger than we need. When you talk about provisional of provisional resource in the cloud, we can talk about resource in infrastructure as a service, in the platform as a service, or in software as a service. In in the IaaS layer, that is the focus of this article, the virtual machines are the resource to be provisioned. Provision of resource in the cloud computing could be manual or automatic. In the manual mode, it's boring and we waste resource. In the automatic mode, we can use auto scalers. So, what is autoscaling? Autoscaling can help us automatically adding or remove virtual machines depends on the incoming traffic of your application. Its goal is to minimize our costs and maximize our quality of service. Autoscaler generally goes through 4 steps: monitor, analysis, plan, execution. First, it monitors application-related metrics, and then it will analyze the observed metrics. And based on the analysis, it will plan on how many virtual machines to add or remove. The final step is simply executing this scaling plan via the cloud provider's API. Why set up an application is hard? The different application consumes different system resources, so it's hard to find good metrics which could reflect the capacity of the virtual machines, which is used to host the application. Provisioning new virtual machines take time to configure and boot up. The outscaling group groups into classes: reactive and proactive. Reactive scaling approach scaling the environment based on current state of the system. The proactive scaling approaches are suitable for cloud environments because they generally have predictable load characteristics, even though they may have unplanned load spikes. What motivates us to explore autoscaling methods? Cloud computing is growing so fast, and there is still not an idea of scaling can help us to use cloud resources effectively. We aim to improve the traditional reactive outscaling, which use the static thresholds to trigger scaling and static value to provision new virtual machines by adding a forecast approach and dynamic thresholds. Make it adapt, adaptive. adaptative. Our proposed hybrid outscaler implements scaling rules, coordinates between reactive and proactive policies, and, and dynamically add or remove VMs in a cluster. Our proposed outscaler dynamically adjusts the thresholds of the input metrics. Our autoscaler allows adequate consumption of the input metrics: CPU, memory, disk, and network. Our proposed hybrid outscaling is component with 5 components. In the beginning, the data collector interacts with CloudWatch and periodically searches for information about the current state of the running application. The data is collected for each node belonging to a cluster of VMs where the application is running. Then it stores the collected information in the data repository. With this information, the reactive component can calculate the thresholds for the elasticity actions. The proactive component consults the data repository for available historical data. With this data, the predictors forecast the next value for the input metrics. The new forecast values available for each model and input metric are sent to forecast chooser subcomponent. We choose only the forecast model with the lowest score for predicting the consumption of each metric. This score is calculated as a weighted sum between the most recent error and the historical error. Finally, the decision maker decides about scale in, scale out, or does nothing. In this figure, you can see the information flow for the hybrid outscaling. So the experimental environment for this work was built on the AWS public cloud. This figure shows the environment implemented in the AWS cloud with bands to evaluate the proposed automated elasticity solution. As can be seen in the figure, Wikband is made up MediaWik application and the Wikjector client. MediaWik is a two-tier application and database. In the experiments, the database layer was composed of just one database, while the application layer was composed of a cluster of MediaWik web servers. For this experience, the focus was on the elasticity of the application layer, and in particular, on how the number of VMs in the cluster changes on demand by autoscalers. We compare two autoscalers. Our hybrid solution was compared with a reactive solution. The emulated AWS autoscaler. The duration of the experiments was chosen to present the behavior of the proposed automated elasticity solution in a shorter, equal, and longer time than the training time of the dynamic thresholds for the experiments 1, 2, and 3, respectively. The experiment results from the table. It's observed that the average response times decrease as the duration of the experiment increases, what indicates that the greatest response times are concentrated at the beginning of the experiments. We can observe from the table that the hybrid solution showed an improvement in comparison with the AWS autoscaling as the duration of the experiment increases. These figures illustrate the elasticity actions during experiment 3, where the value 1 indicates the application cluster has been expanded, a VM added to the cluster. The value -1 indicates that one VM was removed from the cluster, and the value 0 indicates that there was no elasticity action. It can be seen that AWS outscaling enters in oscillation, expanding the cluster size, and a moment later, one VM was removed from the cluster. On the other hand, our hybrid solution avoids the oscillation problem. So the experiment's results show that the hybrid outscaler is a decent method that could improve the traditional reactive outscaler by adding a set of predictors. Dynamic thresholds are important to build a good upscaling. Single static scaling method does not work well in most of the time. As a future work, we hope we can support more cloud providers so that we can compare the price of virtual machines in different cloud providers during scale. Thank you very much. And questions?